Hi guys, today we discussed a technical seminar on face recognition. These contents are discussed in this PPT. The introduction of face recognition is explained now. Everyday actions are increasingly being handled electronically instead of pencil and paper or face to face. This growth in electronic transactions results in great demand for fast and accurate user identification and authentication. Access codes for building banks, accounts, and computer systems often use pins for identification and security clearness. Using the proper pin gains access, but the user of the pin is not verified. When the credit and ATM codes are lost or stolen, an unauthorized user can often come up with the correct personal code. Face recognition technology may solve this problem since a face is undeniably connected to its owner, except in this case of identical twins. Facial recognition. It requires no physical interaction on behalf of the user. It is accurate and allows for high enrollment and verification rates. It can use your existing hardware infrastructure, existing cameras, and image capture devices will work with no problems. History of facial recognition. In 1960s, the first semi-automated system for facial recognition to locate the features such as eyes, ears, nose and mouth on the photographs. In 1970s, Goldstein and Harmon used 21 specific subjective markers such as hair color and lip thickness to automate the recognition. In 1988, Kirby and Sirovich used standard linear algebra technique to the face recognition. Facial recognition. In facial recognition, there are two types of comparisons. That is, one is verification and another one is identification. In verification, the system compares the given individual with who they say they are and gives yes or no decision. In identification, the system compares the given individual to all the other individuals in the database and gives a ranked list of matches. All identification or authentication technologies operate using the following four stages, that is capture, extraction, comparison, match or unmatch. In capture, a physical or behavioral sample is captured by the system during enrollment and also in identification or verification process. In extraction, unique data is extracted from this sample and a template is created. In comparison, the template is then compared with a new sample. Coming to match or non-match, the system decides if the features extracted from the new samples are a match or a non-match. Coming to implementation process. The implementation of face recognition technology includes the following four stages: image acquisition, image processing, distinctive characteristic location, template creation. Template matching. Image acquisition. Facial scan technology can acquire faces from almost any static camera or video systems that generates images of sufficient quality and resolution. High quality enrollment is essential to eventual verification and identification. Enrollment images define the facial characteristics to be used in all future authentication events. This is the pictures of the enrollment images. The top picture is the high quality enrollment image and the below picture is the low quality enrollment image. Image processing. Images are cropped such that the avoid facial image remains and color images are normally converted to black and white in order to facilitate initial comparisons based on grayscale characteristics. First, the presence of faces or face in a scene must be detected. Once the face is detected, it must be localized and normalization process may be required to bring the dimensions of the live facial sample in alignment with the one on the template. Distinctive characteristic location. All facial scan systems attempt to match visible facial features in a fashion similar to the way people recognize one another. The features most often utilized in facial scan systems are those least likely to change significantly over time. Upper ridges of the eye sockets, areas around the cheekbones, sides of the mouth, nose shape, and the position of the major features relative to each other. Behavior changes such as alteration of hairstyle, changes in makeup, growing or shaving facial hair, adding or removing eyeglasses, are behaviors that impact the ability of facial scan system to locate distinctive features. Facial scan systems are not yet developed to the point where they can overcome such variables. This is the template creation of the facial recognition. In starting, the camera recognizes the face of the human, then it will be given to the template generation. In template generation, the image will be converted into the binary code. Before the template generation, already the database will be stored in the PC. It will compare the captured image and already stored image. Both are will be same, then it gives the access. If they are not same, it doesn't give the any access. Enrollment templates are normally created from a multiplicity of processed facial images. These templates can vary in size from less than 100 bytes generated through certain vendors and to over 3K for templates. The 3K template is by far the largest among technologies considered physiological biometrics. Larger templates are normally associated with every behavior biometrics. Template matching. It compares matched templates against enrollment templates. A series of images is acquired and scored against the enrollment so that a user attempting 1:1 verification within a facial scan system may have 10 to 20 match attempts take place within 1 to 2 seconds. Facial scan is not as effective as finger scan or iris scan in identifying a single individual from a large database. A number of potential matches are generally returned after large-scale facial scan identification searches. How facial recognition system works. Facial recognition software is based on the ability to first recognize faces, which is technologically feat in itself. If you look at the mirror, you can see that your face has certain distinguishable landmarks. These are the peaks and valleys that make up the different facial features. VisionX defines these landmarks as nodal points. There are about 80 nodal points on a human face. Here are few nodal points that are measured by the software. Distance between the eyes, width of the nose, depth of the eye socket, cheekbones, jawline, chin. Software. Detection. When the system is attached to a video surveillance system, the recognition software searches the field of view of a video camera for faces. If there is a face in the view, it is detected within a fraction of a second. A multi-scale algorithm is used to search for faces in low resolution. The system switches to a high resolution search only after a head-like shape is detected. Alignment. Once a face is detected, the system determines the head's position, size and pose. A face needs to be turned at least 35 degrees toward the camera for the system to register it. Coming to normalization, the image of the head is scaled and rotated so that it can be registered and mapped into an appropriate size and pose. Normalization is performed regardless of the head's location and distance from the camera. Light does not impact the normalization process. Coming to representation, the system translates the facial data into a unique code. This coding process allows for easier comparison of the newly acquired facial data to stored facial data. Coming to matching, the newly acquired facial data is compared to the stored data and ideally linked to at least one stored facial representation. The system maps the face and creates a face print, a unique numerical code for that face. Once the system has stored a face print, it can compare it to the thousands or millions of face prints stored in a database. Each face print is stored as an 84-byte file. It has the ability to leverage existing image acquisition equipment. It can search against static images such as driver's license photographs. It is the only biometric able to operate without user cooperation. These three are the strengths of the facial recognition. The weakness of the facial recognitions are changes in acquisition environment reduce matching accuracy. Changes in physiological characteristic reduces the matching accuracy. It has the potential for privacy abuse due to non-cooperative enrollment and identification capabilities. The applications of the facial recognition are replacement of PIN or physical tokens, no need of human assistance for identification, prison visitor systems, border control and voting systems, computer security, banking using ATM, physical access control of buildings and areas, etc. The advantages of the facial recognitions are it will be easily to use, convenient social accessibility, inexpensive technique of identification. The disadvantages of facial recognitions are problem with false rejection when people change their hairstyle, grow or shave a beard or wear glasses. Identical teens. Coming to conclusion of the facial recognition, factors such as environmental changes and mild changes in appearance impact the technology to a greater degree than many expect. For implementation, where the biometric systems must verify factors such as environmental changes and mild changes in appearance impact the technology to a greater degree than many expect. For implementation, where the biometric systems must verify and identify users reliably over time, facial scan can be a very difficult but not impossible technology to implement successfully. Thank you guys. If you have any queries, put message in comment box. If you need this PPT, I share the download link in description. Please subscribe the channel for more videos. Bye bye.